All right. If you have been building software for any length of time, you must have heard these three names: REST, GraphQL, and gRPC. And chances are you might have worked with at least one of them, right? But here is the question, and most engineers never get a good answer to that question. And the question is, when do you choose each one, right? And what happens when you pick the wrong one? I have seen teams choose REST for internal microservices and then spend months fighting problems that GraphQL would have solved in a week. And I've seen teams adopt gRPC for a public API and then spend 6 months building SDK clients for every language their users need. So the wrong API choice does not kill a project immediately, but it slows it down and it accumulates as a technical debt. So if you want to build a system, you have to choose the right API that fits your system. So in this lecture, we will give you a clear, practical mental model for choosing the right protocol for the right job, not based on hype, not based on what is trending, based on actual trade-offs. So by the end of this lecture, you will be able to look at any system design scenario and say confidently whether REST, GraphQL, or gRPC is the right tool for that system. And you will be able to explain why to everyone in the room. For example, if you are choosing a REST API, so you would be able to answer the why of anybody. If somebody says why you are using REST, so you might have a reasonable answer for that. So this is very important lecture, and you would be able to understand the right usage of all APIs, REST, Graph, or gRPC. So let's start with the fundamentals. Before we compare these protocols feature by feature, I want to give you a mental model for each one, because the right model in your head is more useful than any comparison table. REST is resource oriented, right? You think in nouns. In REST, everything is a resource, a user, an order, a product. So every API operation is something you do to that resource, right? You get it, or you put or patch to update it, you delete it. The URL tells you what you are working with. The HTTP verbs tells you what you are doing with that resource, right? So the analogy which I want to add is filing a cabinet. You know where everything lives. You go to the right drawer, the right folder, and you pull out the file that is simple, predictable, and everyone knows how it works. Then we talk about the GraphQL, which is query oriented, and you think in graphs. The big idea is that the client knows what it needs. So let the client ask for exactly that. Instead of calling three different REST endpoints and getting back fields you do not need, you write one GraphQL query that describes precisely the shape of data you want, and the server returns exactly that shape. No more, no less. So the analogy which I want to add is a custom report. You go to a reporting tool and you specify exactly which columns you want, and you do not get the whole database, you get your report. Then if I talk about the gRPC, so gRPC is function oriented, right? And you think in function calls. You define a service with methods, and the client call those methods as if they were local functions. So under the hood, the call goes over the network, but from a code perspective, it looks and feels like calling a local function with strong types, compile time validation, and fast binary serialization. So the analogy which I want to add over here is a phone call to a colleague, right? So you say exactly what you need and they do it. They reply. Direct, efficient, and no ambiguity. Three protocols three different ways of thinking, and your job as an architect is to match the thinking style to the problem. Now let's compare these three protocols feature by feature, right? Imagine you are at a restaurant and you are very hungry, and there are three different waiters walk up to you. One named REST, the other named GraphQL, and the third one is named gRPC, right? Each one works completely differently, and your job is to understand how each waiter operates so you can pick the right one for your kitchen. So let's go feature by feature and compare each protocol, each API. If we talk about the transport feature, right? So the transport is a kind of road which is used by the API, right? So REST and GraphQL are flexible. They can work on old dirt roads like HTTP 1.1 or brand new roads like HTTP 2, but they don't care which one, they just get going. And gRPC is different. It only travels on the modern highway like HTTP 2, and it refuses to use old roads. But here is the thing, because it only uses the best road, it goes much faster on it. So if your system is old and does not support HTTP 2, gRPC is not the correct option. gRPC simply won't work for you. But if you have the modern infrastructure, and then gRPC will outrun the other two every single time. Then if we talk about the data format, so now imagine the food arrives and how it is packed, right? REST sends you a nice readable lunchbox JSON format. You open it and you can clearly see like rice, chicken, salad, and a human can read it, a machine can read it. Everyone's is happy. Sometimes it also uses XML, which is like a more old-fashioned lunchbox. And GraphQL also sends a clean, readable JSON lunchbox, always JSON, no surprises. And gRPC does something completely different. It sends your food in a vacuum sealed compressed packet called protobuf, short form of protocol buffers. So this packet is tiny and lightning fast to deliver, but you cannot open it with your bare hands, and you need a special tool because it's in binary, right? And meaning it's written in the language of machines, not humans. So REST and GraphQL are easy to read and debug by looking at the data. gRPC is faster and lighter, but you need proper tooling to work with gRPC. And then if we talk about the schema, so a schema is like a restaurant menu. It tells you here's what we serve, and here's how to order it, and here are the rules, right? So REST says that a menu is optional. Some REST APIs come with the clear documentation called Open API, and others you just have to figure it out as you go. But it can get messy. And GraphQL says we have strict detailed menu, and it is strongly typed. That means that every single item is defined, every ingredient is listed, so there are no surprises. If you ask for something that does not exist on the menu, GraphQL immediately tells you that sorry, we don't have that. And then we have gRPC, goes even further. It says before we even open the restaurant, you must sign a contract, and that contract is called proto file, right? Both the client, which is the customer, and the server, which is in our case, in our analogy, is the kitchen, must agree on this file before any communication can happen. So it's locked in, and this makes gRPC incredibly consistent, but it also means more upfront work. Then if we talk about the flexibility, this is where things get really interesting. REST gives you fixed meals, right? Think of it like McDonald's combo. You order combo number 3 and you get the burger, the fries, and the drink. That's it. Even if you only wanted the burger, you still get the fries and the drink. You can't easily say, just give me the burger. And in developer terms, when you call REST endpoint, you get back all data that endpoints is programmed to return. Even if you only needed 2 fields, you get all 30 fields. And this is called overpitching. And GraphQL is the opposite, right? It's like build your own meal restaurant. You walk and say, I just want the chicken, no sauce, half portion of rice, and extra vegetables. So the kitchen gives you exactly that, nothing more, nothing less. So this is GraphQL's biggest superpower. You ask for what exactly you need. And if we talk about the gRPC, so gRPC is like a vending machine. You press B3, you get B3. You press C7, you get C7. It's fast and reliable, but what it gives you is fixed. The methods are defined in advance, and no customization and no improvisation. And then if we talk about the performance, REST is like a solid, reliable family car. It gets you to your destination well, no complaints. And GraphQL is also a solid car, about the same speed, maybe slightly different fuel type, but broadly a similar performance. And gRPC, same destination, but it arrives 2 to 10 times faster. That's not an exaggeration. That's what the benchmark says, right? So why gRPC so fast? Three reasons. Based on 3 reasons, we can say that gRPC is fast. The first one is the binary data is much smaller than a JSON text, and less data to send means faster delivery. The second reason is that it uses HTTP2, which lets gRPC sends multiple requests at the same time on a single connection. So instead of waiting in line one by one, the connection is built and the data is sent all at once. And reason number third is protocol buffers are extremely efficient to encode and decode, and the machine processes them almost instantly, right? So for small app with 100 users, this might not matter much, but if you are working at Google or Netflix and your servers are talking to each other millions of times every second, so at that scale, 2 to 10 times faster is the difference between smooth and crashing. Then if we talk about the browser support, so this is gRPC's biggest weakness, and it's important to understand, right? REST works natively in every browser, and Chrome, Firefox, Safari, Edge, any browser can be used to access REST API. They all speak REST fluently. You open a web page, it calls REST API, everything works, no setup needed. And GraphQL also works natively in browsers. It travels over regular HTTP, which every browser already understands. But gRPC, browser do not speak gRPC natively. If you try to call gRPC service from a browser, it won't work. You need a special adapter called gRPC web sitting in the middle to translate. So this is why gRPC is almost never used for apps that users open in their browsers, right? So instead, it's used behind the scenes. Servers talking to server, microservices are talking to microservices, where browsers are not involved. So think of it as the communication happening deep in the kitchen, not at the front counter. And then if we talk about the streaming, so streaming means instead of one request getting one reply, data keeps flowing continuously in real time. REST can do the basic streaming, by using something called SSE, server sent events. And think of it like a radio broadcast. The server pushes updates to you, and but it's one way only, and you listen, you can't talk back to the server. And GraphQL has something called subscriptions. Think of it like following a live news feed. Whenever something changes on the server, so it pushes the update to you automatically. And that's great for real-time dashboards, live scores, or notification systems. And gRPC supports native bi-directional streaming. Think of it like a real phone call. Both sides can talk and listen at the same time, simultaneously, live, right? So this is incredibly powerful. It's perfect for chat applications, live video feeds, multiplayer gaming, or any situation where two systems need to constantly exchange data in both directions at once. Now, if we talk about the learning curve, like which one is easier to learn, so REST has low learning curve. It's like riding a bicycle. Almost every developer in the world already knows it. You can hire for it easily, right? So you can find tutorials, answers, any help everywhere. When something breaks, debugging is simple because the data is readable JSON file, right? GraphQL has a medium learning curve. It's like driving a car, more powerful than a bicycle, but you need some lessons. You have to learn how schemas work, how to write queries and mutations, how to handle subscriptions. It takes time, but it's very learnable. Then if we talk about the gRPC has a high learning curve. It's like learning to fly a plane. Very powerful in the right hands, but you need to understand protofiles, code generation, HTTP2, binary encoding, and proper tooling. If your team does not have time to learn it properly, it can cause more problems than it solves, right? So here comes the golden line at the bottom, and it's the most important thing of all. No protocol wins on every dimension. The winner is always the one that best matches your specific access pattern and team and client ecosystem, right? So here's how you remember it very simply, and that is you use REST when you are building a public API and your team is small, or you want something that works everywhere without any special setup. It's the bicycle, not the fastest, but everyone can ride it. And then you can use GraphQL when your app, especially a mobile app or complex front end, needs to pitch exactly the right data, no more, no less. So it's the car, more powerful and more control, worth learning, right? Then if you want to use gRPC, so you can use gRPC when two servers need to talk to each other at extreme speed. So you control both ends of the communication, and your team is experienced enough to handle the complexity. So it's the fighter jet, right? Incredible performance, but you need a trained pilot. So pick the right tool for the right job, and you will never go wrong. Now let me give you a very direct framework for when to use REST, when the REST API is the right choice. So use REST when you are building a public API. If external developers, third-party partners, community builders, enterprises integrating with your platform, and if any of them need to consume your API, so then you can definitely use REST. It is the universal language of web APIs. Everyone knows REST API, and every language has a library for it. So every tool supports it, and you reduce the friction of adoption to near zero. Use REST when your operations are simply CRUD, right? If most of your API is create, read, update, delete operations on well-defined resources, so then REST is the best option for you. REST maps to that naturally. and you are not fighting the model, you are working with it. Use REST when team has mixed experience level. You do not need to train anyone, you do not need to set up a code generation pipeline, you do not need to explain a query language. Everyone knows how to make a GET request. And use REST when the browser is your primary client. Native pitch support, easy debugging, and dev tools, intuitive HTTP caching. REST and browsers are, they were built for each other. Now, I would like to tell you that when to avoid REST. When should we not use the REST API? Avoid it when multiple clients need very different shapes of data. If your mobile app needs 5 fields from the user object, your web app needs 20, and your analytics dashboard needs aggregated data, REST forces you into one of two bad choices, right? So either you create multiple endpoints for each client, which creates maintenance chaos, or you return the full object to every client, which wastes bandwidth. And that is exactly the problem GraphQL was built to solve. Avoid REST API for high frequency internal microservice traffic, right? If service A is calling service B tens of thousands of times per second, so the overhead of JSON serialization and HTTP 1.1 connection management becomes significant. That traffic belongs on gRPC. So look at the real world examples. Stripe uses REST, and GitHub v3 uses REST. Trello uses REST. All public APIs, all serving developers who need a simple universal interface. So REST is not old-fashioned. It is the right default for the right problem. You need to know what the problem is, and then you have to identify. You have to choose whether you want to go with the REST API. REST is the best fitting or not. Now let's talk about the GraphQL. When should we use GraphQL? GraphQL was born out of a very specific pain at Facebook in 2012. They were rebuilding their mobile app. So the Facebook news feed was nightmare. The mobile team needed one set of data, the web team needed another. So each time a feature changed, the API team had to ship a new endpoint, and it was slow, it was fragile. GraphQL, was their solution. It lets the client describe what it needs and let the server fulfill that description. One query language, one endpoint, and every client gets exactly what it asked for, right? So use GraphQL when you have multiple clients with different data needs, like mobile needs lightweight responses to conserve battery and bandwidth. Web can handle richer payloads. So admin dashboard needs aggregated views. With REST, you either create separate endpoints for each client and maintain them separately, or you overpitch on the lightweight clients. GraphQL solves that problem. And use GraphQL when your product is iterating fast. In a startup or a product-led team, the front end is constantly changing. With REST, every front end change that needs new data requires a backend change. So with GraphQL, the front end team queries for new fields as soon as the backend exposes them in the schema. No coordination required. And then use GraphQL when you care about bandwidth. Overpitching is real. Like if your REST API returns a user object with 40 fields and your mobile app uses only 5 of them, so you are wasting bandwidth on every request. On mobile, bandwidth is money, right? So GraphQL returns exactly what you asked for. Now let's talk about when should we avoid GraphQL, right? So avoid GraphQL for simple, stable apps. If your API has 5 endpoints that never change, and all clients need same data. So GraphQL adds a query layer, a schema layer, and a resolver layer for no benefit. Then you can definitely consider REST API instead of using GraphQL. Avoid GraphQL for binary data transfers. GraphQL is built around JSON, and file uploads exist but are awkward. They require multi-part workarounds, right? So binary streaming does not fit the model at all, and use the REST or gRPC for those needs. And the real systems which are using the GraphQL, GitHub moved from their v3 REST API to v4 GraphQL API because developers were making dozens of requests and assemble the data they need. And GraphQL let them do it in a very one query, right? And similarly, Shopify uses GraphQL for exactly the same reason. Their storefront API serves iOS, Android, and web, and third-party integrations, all with different data needs. Now let's talk about the gRPC. When should we use gRPC? gRPC is the protocol that most engineers discover later and wish they had known about earlier. It was built at Google to solve the problem of high performance internal service communication at massive scale, and it does that job better than anything else available today. So use gRPC for internal microservices communication. When you have dozens or hundreds of services talking to each other hundreds of thousands of times per second, so the efficiency of gRPC is transformational, and binary protobuf serialization is significantly smaller than JSON. And also HTTP2 multiplexing means multiple requests share a single connection. So the cumulative effect is 2 to 10 times less CPU and network overhead compared to the rest. Use gRPC when you operate in a polyglot environment. One protofile generates type, SAP, client, and serve code for every major language like Go, Java, Python, C++, Node, Kotlin, all from the same definition. So this is massively valuable in a microservices architecture where different services are written in different languages. Use gRPC when you need streaming. This is where gRPC has a capability that REST simply cannot match. And gRPC supports server-side streaming, like client-side streaming is also supported in gRPC, and which means that they provide fully bidirectional streaming out of the box. If you are building a telemetry pipeline, a live analytics feed, or a real-time collaboration tool, so gRPC streaming as the cleanest solution. And use gRPC when you want contract first API design with compile time enforcement. So the protofile is the contract. If you change a method signature in a way that breaks existing client, it is a compile error before it even reaches the production. Now, when should you avoid gRPC? For public APIs and browser that cannot call gRPC natively, so you need gRPC Web, which adds a translation proxy. For any API that external developers or browsers consume directly, the friction is not worth it. Then we can use REST or GraphQL instead of gRPC. For simple low traffic services, the Proto toolchain, installing Protoc, writing proto files, running code generation, add real setup time, right? So if your service handles modest traffic and the performance gain does not matter, so this complexity adds cost with no benefit. And where exactly gRPC is used in real systems, so Google and Netflix and Cloudflare these three systems are using gRPC. Google uses gRPC internally, Netflix uses it across 700 microservices, and Cloudflare uses it at the edge, right? So these are all internal service architectures and not public APIs. That pattern is intentional. Now here's the question: can we use all of these protocols, all of these APIs inside a single application? So the answer is yes. Here's something that surprises many engineers when they encounter it for the first time. Most large-scale systems at real companies do not use just one of these protocols. They use all of three deliberately, and each one in the place where it fits best. Look at this architecture diagram. At the top, you can see that we have different clients, a mobile app and a web app, and then we have third-party developer. So these are external consumers who need an API, and that talk to an API gateway, right? And then the gateway accepts REST for third-party developers, and because REST is the universal language of public APIs, it accepts GraphQL for the mobile and web apps because the mobile team needs lightweight queries and the web team needs rich data. And GraphQL serves both from a single endpoint, and behind the gateway, the internal services talk to each other using gRPC. You can see gRPC over here. So every call between the user service and the order service is a gRPC call. Every call from the order service to the payment service is gRPC. Fast, typed, and efficient. So this is the architecture that Netflix uses, that Google uses, that Shopify uses. So the boundary between external and internal is the boundary between REST, GraphQL, and gRPC. So let me make this concrete. Your mobile app makes a GraphQL query to the API gateway and to load the user's order history, and then the gateway receives that query and translates it into gRPC call, and one to the user service and one to the get the details from the user module, and one to the order service to get their orders. So it assembles the results and returns the GraphQL response. And the mobile app sees GraphQL. The internal services never sees GraphQL. They only see gRPC. So this is the practical answer to the question, which one should I use? In a large system, the answer is often all three, each in its lane, right? Now I want to give you something practical you can use immediately, a decision, a flowchart, which includes 4 questions, and you get to answer in under a minute, right? So question number 1 is is this API public facing or consumed by a browser? If yes, so then use REST API and then full stop, right? So browser compatibility, developer familiarity, and universal tooling support makes REST the unambiguous choice for anything external. Then question number 2 is do different clients need shapes of data, right? If different clients need different shapes of data, so you have, for example, mobile, web, and third-party clients, and all needing different fields from the same underlying data. So then you can use GraphQL, and this is the defining use case for GraphQL. If all your clients need the same data shape, then you can go with the REST API. But if all of them needs different shape of data, so then you can select the GraphQL instead of using the REST API. Then question number 3 is is this high throughput internal service communication? If you are building microservices that talk to each other at scale, So then you can use gRPC. The performance advantage is real and material. If this is a low traffic internal service, so where performance does not matter much, so then you can consider some other API. Then we have question number 4, and question number 4 is, do you need bidirectional streaming? If yes, so then you can use gRPC. It is a native streaming support that REST cannot match. If no, so then you can use the REST as your SAP proven default method, right? So the most important thing about this flowchart is what it reveals about how to think about the decision. Start with your client who is consuming this API. External developers and browsers push you towards REST API, and a diverse internal clients pushes you toward GraphQL. Internal services pushes you towards gRPC. Then ask about your data access pattern. Does the client need to specify what it wants? So then you consider the GraphQL. Does it need to call a specific function at high speed? So then we can consider gRPC. Does it need to perform standard resource operations? So then we can consider the REST API. So you use this flowchart every time you design a new API boundary. It takes 60 seconds and it saves weeks. Before I conclude this lecture, let me give you an assignment, and here is your action item. It is a practical audit. Look at your current system or any system you know well and list every API boundary, every place where one component communicates with another, right? Every external endpoint, every internal service call, and for each one run through the decision flowchart, and is it using the right protocol? Be honest. And you may find REST where gRPC belongs. You may find REST where GraphQL would serve multiple clients more cleanly. If you find one API that is using the wrong protocol, write down your reasoning. What signals tell you that it is mismatched? What would you switch to? And what should be the cost of switching versus the benefit, right? And if you have a REST API today that serves both a mobile app and a web app with different data needs, sketch what the GraphQL schema would look like. And you do not have to implement it, just sketch it. And the exercise of writing the schema will show you immediately whether GraphQL would simplify things or complicate them, right? So this audit is one of the most valuable exercises you can do, and it trains your eyes to see protocols mismatches, and every senior architect I know can spot these mismatches from a system diagram in seconds. So in next lecture we go one level up. Instead of looking at individual API protocols, we look at a layer that manages them all, and then the API gateway pattern. So it is one of the most important architectural patterns in modern distributed system. See you there.
Thank you so much for watching this. Before you go, please don't forget to subscribe to my YouTube channel and turn on the notification bell so you never miss any of my upcoming videos. I regularly share valuable lessons, practical tips, and step-by-step tutorials to help you improve and grow. And if you are serious about mastering software design and architecture and want a complete structured learning experience, so I have created a full course that includes detailed lessons, assignments, quizzes, and downloadable workbooks to help you practice and apply what you learn. So if that sounds helpful, just check the link in the description below and enroll in the course today. I would love to see you inside and support you on your learning journey.